Hello everyone. My name is SaiSrikanthPodugu. My student ID is 11625099. Today I want to discuss with you all about my deep learning with big data project. First, we'll talk about what is artificial intelligence and the history of artificial intelligence. So, before knowing about the history of artificial intelligence, first we need to know about artificial intelligence. Artificial intelligence is nothing but simulating human intelligence process by the use of machines, usually computer systems. Machine learning and deep learning are the technologies that have been introduced to artificial intelligence. We will discuss this next during the history or during the discussion of history of AI. It all started from the year 1642, where a French mathematician and investor named Blaise Pascal first built a calculating machine. And slowly from then, in 1943, McCulloch and Pitts established the foundations of neural networks, which is a technology that builds the connection between the brain and computing machines. From this time, the pioneers or researchers started to dig deep into these neural networks and how to connect the machines to human brains. And in 1955, the artificial intelligence name came into limelight. As there are not many high computing resources available, artificial intelligence has not been more popular. But in the year 1997, a computer AI program beat world chess champion Gary Kasparov, and from here the evolution of AI has been kept increasing, and also its significant usage has also been gradually started. But from the year 2002, AI has launched a vacuum cleaner named Roomba that cleans everything, avoiding all the obstacles. Slowly seeing all this, AI has started inventions in every industry. Keeping all these inventions and developments aside, 2011 IBM's Watson defeating champions, the development of personal assistants such as Siri, Cortana, and other chatbots started using speech recognition technique. Uh, from 2011 to 2014, people started recognizing and using the artificial intelligence technology more frequently. But in 2016, when AlphaGo beat with the professional Go player Lee, deep learning has been taken all over the internet. So first we'll discuss about what is deep learning. Deep learning is a subset or part of machine learning, and machine learning is also a part of artificial intelligence. So deep learning is a type of machine learning which is like the structure of human brain. Uh, and the structure is same as human brain. The working of the deep learning algorithms and its conclusions are also similar to that of humans by analyzing the data provided by logical structure. In this process of achieving conclusions that are similar to the conclusions of human brain, deep learning uses multi-layer structures of algorithms called neural networks. So in this project, uh, I have used TensorFlow version 1.xx in coding, and I haven't used any Keras to build or train and test the convolutional neural networks. So this is the Indian vehicle data set that I have chosen for the part 2. So this data set is collected by Data Cluster Labs. Uh, this consists of all the vehicle images collected from rural, urban, and city areas in India through cell phones, and lots of processing is done at the Data Cluster Labs. As these images are crowdsourced and will go through a thorough check from computer vision professionals at the Data Cluster Labs. And this data set contains around 50,000 plus images and are captured by over 1,000 plus crowdsourced contributors. Hmm. And the resolutions of all these images are 100% images or HD, and it's above 1920 into 1080 pixels and above. Mm. And coming to the location of the images took here, and the location is like all over India. Uh, and also the device used are the mobile phones, which mobile phones, and the year of the and the year where these images have been taken are from 2020 to 2022. And all these images are about vehicle detection, automobile detection, construction vehicle detection, and self-driving systems, etc. And if I come to the part 3, here I have uploaded the CIFAR 10 dataset into virtual machine Jupyter notebook. So I will talk about how I uploaded the CIFAR 10 dataset into the virtual machines Jupyter notebook. So first, I have downloaded the dataset from the reference link which have been provided by Professor Tuan. And then once I had downloaded the dataset onto my local machine, then I had opened my GCP account, and from my GCP account I have opened a project, and from the project I went to the compute engine, and in the compute engine first I have started my virtual machine instance. And once I have started my virtual machine instance, then I have opened the Google Cloud SDK shell, which I have been installed onto my local machine. And then I have connected to the PuTTY server using the location as US South 1C and my virtual machine instance. And I have logged into the PuTTY server, then I have created a directory named JP_NTBK, means it's like Jupyter notebook, short for Jupyter notebook. Then once I have created the directory, then I have changed my path to the directory which I have created with the code cd jp_ntbk. Then once I have changed into the directory of Jupyter notebook, then I have created a directory or a folder named CIFAR_10_data. So once I have created the CIFAR 10 data, then I have uploaded my CIFAR 10 dataset into the Jupyter notebook. So here you can see, right? So this is the JP_NTBK is the folder that I have created. And then once I have been into that folder, then I have uploaded all those 7 files of the CIFAR 10 data from a local desktop to the virtual machine Jupyter notebook. So now after the uploading of the CIFAR 10 data set, now the part 4 is like creating the CNN network architecture diagram and then building the test modules, test models, and everything. And also before creating the model, we have to design the CNN network architecture based on how many convolutional layers do we want, or how many pooling layers we want to use, and all those things. So before designing also, we need to get an idea of the CNN network architecture. So here we can see that this is a CNN network architecture diagram. So here we can see, here you can see all those layers that have been present in the CNN network architecture. So the first is the input image. Then the input image will be fed into the convolution layer 1, and then from the convolution layer 1, the input image will be becoming as output, and then it is fed into the pooling layer 1. The pooling layer 1 will take the output of convolution layer 1 as an input, and then it sends the output to the convolution layer 2. Then convolution layer 2 will take the output of pooling layer 1 as an input, and it sends the output to pooling layer 2, which again pooling layer 2 will take it as input, and then the input that has been got to the pooling layer from the convolution layer 2, on that input will apply flattening. Once the data gets flattened, then the data is fed into the fully connected neural network, where we use ReLU activation. So after that, and in the same step, we'll also drop out some records. And after dropping out the records, then they will send the data which he had came which we had as an output from the fully converted network as an input to the output layer. And from the output layer, it calculated all the bias and weights. Then it will provide us the output